Thanks for joining this session. We're going to talk about using AI in our local development, and that means you can interpret that in different ways, I guess, right? Because local development could mean, well, I'm doing my local development with AI, but it can also mean using AI locally on my laptop, which is what we're mainly going to focus on. But we're also going to use some local models to do our development and integrate them into our local applications. I'm Kevin Dubois. I'm a developer advocate at IBM, and Cedric here. We used to be in the same team at Red Hat.
The same team.
Yeah.
He's so far, but so close.
Yes, exactly. Yeah.
But thanks, guys, for being here. We appreciate it. There's a couple things we're going to cover today that has been on my mind a lot recently, and probably yours as well. Models are getting very expensive. So the latest 5.5, which came out this month, there's a pro version of this, and it's $180 per million output tokens. And for reference, the typical average we were dealing with is like $5-10 per million output tokens. Now, this is the frontier model, and typically what's happening is we're all adopting this in Claude Code or Cursor or local development environments to speed us up, right? To be, 10x developer. And so what happens is this is going to become maybe the standard, right? These models are going to be very expensive, but we're going to be using them for all of our software development work. And I know for one, I don't like to be kind of locked into one specific solution or one way of doing things. Because what happens if Claude isn't working one day, right? And you've been dependent on it, everything's based around it. And so the idea for this session is to help you guys be independent and to use these local models.
So maybe a quick question before we keep going. So who here uses a code assistant right now?
Oh.
Yeah, fair amount. And how many of you use Claude? Okay. And how many use Codex? Couple? Okay. And so, yeah, it's more of a mix than I expected, because I only hear Claude these days. It's crazy. But yeah, I mean, that's exactly what you're talking about, right? It's so easy to get locked into one of these vendors because it's, kind of the latest and greatest. And we think like, well, it's not that hard to switch to a different vendor. But it kind of is.
And if it isn't now, it will be in the future for sure.
Yeah.
So we don't want this to be your situation, right? Where you're just like, what happened? And just from what I see, I spend too much time on the internet. My screen time is out the roof. And we're seeing, for small models, it's not too bad, right? These Flash type of models, Sonnet or Haiku models from Claude. But the main ones that you end up using for coding, right, are $25 or more per million output tokens. Just as a quick example, I use a tool called Goose. It's part of the open source AI foundation of the Linux Foundation. And with about 50 sessions of just a few conversations back and forth with the model and using MCP servers and tools, I'm at about 3 million total tokens used. And so if we're using one of these state-of-the-art models, that ends up being $100. $100 just for me to call an AI. That's crazy.
So what are German emojis, by the way?
I don't. I'm scared now. I don't know. But this could be you after an hour of vibe coding, right? You're like, what happened? Where'd it go? Did anyone hear the news about Claude might be getting rid of the $20 coding plan? This kind of came about last week, where they did a kind of canary experiment where they said, we're going to show a small portion of our users that there's no more pro plan for Claude Code. And people were like, no. And so even if you didn't see that yourself, you might have hit rate limits before when using these proprietary models. GitHub just paused new signups for Copilot, if you saw that as well. So a lot of things are changing right now in the industry, and I think this is a really important topic. So that's why this kind of open source angle and open models will help you avoid feeling like that, right? So convenience is one of the biggest factors too, right? Because some of the demos we're doing today using this local model just call localhost. And so what does this actually look like? Well, when we're running a model, whether it's with Ollama or LM Studio, one of these different tools, we're essentially just starting an inference server. So this is called Ramalama. It runs an LLM in a container. So you can see what's happening is it's loading the model weights to this bad boy's GPU, and it's starting it on port 8080. So it's a REST API. And then what we can do on the other side here is, send some requests to this model. So Should we try it?
We should try it.
Should try
Both
it.
of us. We haven't tried that.
Yeah, we actually didn't try it yet. What it's doing is it's taking the input from the camera, encoding it in base 64, sending that to the model, which can work with images, text, and
Oh, okay.
yeah, pretty good. Yeah. So not bad, right?
What's this graying hair stuff about?
I think it's hallucinating.
Yeah, must be you.
What does this person look like? It's totally a celeb. Trust me, bro. You know, they can easily be gaslit into thinking things. So let's try it one more time. Ryan Reynolds. Okay, come on. It's not bad. It's not hallucinating.
Yeah. Now, which one of us is it, though?
So, you know, it's cool. You can see everything happening in the background. This isn't a container, so we could use Docker or Podman. But this is the premise, is we're kind of like serving a web server, right? We're loading in the model, serving it as a REST API, and we can make requests to it. And that's kind of the backbone about why you want to run these models locally is, instant responses, everything's local. Because one thing that I also saw recently, does anyone see this news about, SpaceX looking to acquire Cursor for too much money, maybe? 60 billion, that's...
Right.
Yeah, that's chump change.
Exactly. And the big question is why, right?
Why, exactly. One of the biggest reasons, though, they cited is because we're running out of human-curated data, right? There's not enough Reddit conversations to be able to scour for these models. And so our data using something like Cursor or Claude is being used in this, new age of LLMs. So what's also really cool is that you could run these models on a computer, like the example we did here. But I also want to show you, let me AirPlay to the computer real quick, that you can run them even on your phone. Has anyone ran a model on a phone before? Okay, one guy in the back. It's my guy. Let's give a prompt. This is an application called Locally AI. It just uses the hardware acceleration on the phone to run all types of models. So it could be the Gemma models that just came out recently, Quen models, the European Ministral models. What should we say? Let's just try it.
I don't know.
Tell my boss I'm, sick and can't make it tomorrow. As you guys know, we have a DevRocks party going on tonight. So you could use something like this. Keep everything private.
By the way, if you don't have your ticket yet, it's at the Red Hat booth, I heard.
Exactly.
Free tickets.
This is pretty good. Oh,
wow.
I would write something like this. Dang. Okay. So just an example of,
I love the emojis, too. That's what you want to send your boss,
muscle
right?
emoji, muscle emoji. We'll get back at it. So models can be ran on your local device, on your phone. You keep all of that data private. And you don't have to worry about proprietary information going to a model. But
yeah. I mean, there's also the environmental part of it, right? So have you seen these stories of Google wants to build a new data center there and Microsoft there, and it's crazy. And then you hear these stories where they run out of water in some towns, and other towns they have power outages because there's just data centers, and everybody, all the local governments, they're vying for these data centers because they're like, oh, it's money and jobs. But yeah, there's a really kind of dark side to this. And and I'm guilty of this, you're guilty of this, I'm guessing most of you are guilty of this too, is just kind of using AI because it's available and we can use it as much as we can. But in reality, these data centers are actually there consuming all this energy and kind of destroying our planet a little bit. So again, I'm guilty of this too, but it is something that we definitely want to keep in mind. So, and that's kind of what the session is about, not about saving the planet, because unfortunately, I don't
think we're equipped for that.
Yeah, but why should we run these models? I think there's several reasons that you've seen now. And how can we run these models locally on our laptop in a way that we can actually use them in our workflows as well, right? So how do you choose the right model to do that? Because there are so many out there, and every day there's a new one, the latest and greatest. But is each model the same, or are there different kinds of advantages to using different models? And can we use local models for our development? So if anybody was in my session this morning, where I showed you how to create agentic applications with Java, I was not using a local model because it was just a little bit faster for my demos than not. Again, I'm guilty. In this session, I'm going to show you how to use local models to do the same thing. So, and kind of weigh also when to do that and when you do have to resort to, kind of the bigger cloud-based frontier models. And then, how can we use those local models? So we'll go through all of that, hopefully in the next 35 minutes. So
it'll be fun.
Yeah. So we'll start with running your own AI and LLMs, and then we'll tell you how to choose the models and integrate it and everything. And then the slides are already there. So if you don't want to wait until the end, then you want to grab the slides and then duck out. Please don't. But
I hope that. Yeah, I think it should work. I hope.
Maybe it's the previous version of the deck, but it'll be very similar.
It'll be relevant.
Yeah.
Cool. So Kevin, I want to try a local model, but I mean, which one? Because as you know, if I come over to Hugging Face, right, which is kind of the GitHub for AI models.
Has anybody tried to go to Hugging Face and pick a model? It's overwhelming, right? It's like, wait, okay, this is cool. There's so many models, but which one should I pick? And yeah, there's like almost 3 million now. To be fair, a lot of them are very similar. They're just different copies, slightly trained differently by somebody that then put them on Hugging Face as well. But regardless, there's a lot to choose from, right?
Yeah.
So how do you choose your model from there?
That's a great question. I mean, to be honest, Kevin, I kind of use this analogy of video games because, I mean, that's where I spend all my time.
Who knows this one? Yeah,
anyone know this one? Raise your hand. Yeah, my people.
Come on, don't be shy. Come on.
Mario Kart or Beerio Kart, as we like to say as well. So just like you're picking a character, you're going to choose based on your use case and the advantages. So several that we'll look at today, including the one that was on my phone, just like Quinn right here, are open source or at least open weights. So you don't have the source code training data, but you do have the kind of binary executable that you can run on your computer, your phone, wherever you're
and like just like the analogy here, right? So you have each character has their strengths, their weaknesses, their kind of special powers, and it's exactly the same for the model. So we showed a couple of them here. Of course, there's many more. I was just thinking of the llama models. They were really popular like 2 years ago, and I don't know if Meta is really pushing those as much as they were.
I'm not sure. Anyway. But that was originally the most popular model. Now, I think Quinn is the #1 model in the world.
Yep.
From downloads.
Yeah, so which model to select, it kind of depends on your use case and the scenario that you're using it for. And that's where you really need to keep in mind. You can't just use one model and think it's going to solve all your kind of use cases. It can, maybe, but not as good as if you choose the right model for the right use case. So we gave a couple examples here. This is a non-exhaustive list and changes every day. But like the DeepSeek, GPT-OSS, Gemma, those kind of models, they're more generalized models, and they're pretty good at doing like reasoning tasks and complex problem solving. So if you have like something where you want to ask it to do some sort of reasoning and maybe some complicated question or something, these models are pretty good at that. If you want to use a model for your local code assistant, you want to use a model that is kind of trained specifically for this. So there are several of those out there. So there's QuenCode, there's Kimi, Devstral, Minimax. There's a couple more, but these are kind of the main ones right now. Ask us again tomorrow, might be different. And then if you want to have also models that are very fast and just small, very small models that you can use to ping really quick and get a quick result that you can also use for some special training on top of it, Granite models are really good at that too. And they're pretty small, so
yeah, exactly. And they might be fine-tuned for coding or fine-tuned for, say, for example, vision. A good example I like to show is just this little Python notebook here where we're using an API like Ollama. So remember before we had, we were running Ramalama, which starts an inference server. Ollama does the same thing on port 11434. So by seeing if it's available, we can try to do some picture classification, because a lot of LLMs just work with text, right? With code, they do very well there. So let's say, for example, you have diagrams, images, charts, etc. Being able to read those is also really important. And models like the Quen one I had on my phone, or this one that we used, which is also Quen here, can also view text. And so that's really important. So we're saying, hey, I want you to turn this into an image description, right? So there's a little fix here for Apple Silicon. Don't worry about that. But essentially, we're saying with Dockling, which is a PDF parser.
Has anybody heard of Dockling
before?
Project?
Okay, cool. This is for the RAG folks in the room who want to take their documents and convert it for an LLM. And you can say, hey, I want you to create a PDF pipeline using one of these vision models and give us a detailed description of what's happening in the image. Because if we're just using something like OCR, we can see where the bounding boxes are in a document, but we actually can't tell what the images are. And so you can use one of these local models at the same time to say, hey, give me a caption, give me a description of this, and link to the actual image. So these models work really well with code, but also images and other types of formats where you might be doing data analysis, stuff like that. And so it's not just limited to text models now. We're kind of got these multimodal by default LLMs that can do vision, audio, and text, which is really cool. So, should we talk about the price again?
Yes.
Okay.
Everybody likes to talk about prices.
I think it's an honest conversation we have to have. One of the ways to do this evaluation is maybe by intelligence, so how smart a model is based on benchmarks. You can see the latest models here, like that $180 model, along with some open source models like Kimi K2, another Asian lab here, and these kind of rank almost in the same area, but you can download some of these, right? Speed as well, so how many tokens per second, and the price. Of course, you see Claude, Opus, and GPT here. On the other side, you see the open source models, right? Tenfold decrease in price, which is really cool. So this is just one of those websites that I highly recommend you go to evaluate before you deploy or request resources for your environment. Yeah. And then how do we tell between proprietary and open source models? So if only there was a way that we could crowdsource a bunch of people's honest reactions, because you could reverse engineer a benchmark, right? One of these evaluations, some of them are open source, so why don't you just put the answers in the model, right? That's smart. Tell my boss I'm sick tomorrow in Slack. And when we send this request, it's going to query two different models. One of them might be open source, they both might be open source, or they both might be proprietary. And so while that's going in, you can kind of see people evaluate the vibes of these models in different types of scenarios. So the ones we care about is really coding here. And so you can see a lot of the top ones are Claudes, right? But GLM, we see, it's not open source anymore, dang.
There you go.
You hate to see it. But Kimi K2, Ernie, so a lot of these open source models, it never went through. That's okay.
Yeah. But at least now you have an idea how you can do the battle of the LLMs and see which one wins based on those scenarios.
Exactly.
So if you go to Hugging Face and you'll see the model names, there's also a way to kind of try to figure out what exactly those models are for by the naming convention. So you can see here kind of some examples of models. So IBM has their Granite family, and so you can see the family name is typically the company that's behind it, and then you have the model architecture and version. So in this case, we have Granite 3.0, and then how many billion parameters? Typically billion, I guess it's not always. Sometimes it's million. It's actually really small models. And then that last part is really kind of key too, is that base part. So base, it can also be code or it could be instruct, and that basically tells you what you can use that model for. A base model is a model that you wouldn't necessarily just use. It's a base model that you can actually use to fine-tune and create a more trained version of. And then, for example, instruct means that this model is something that you can give instructions to, or code obviously is more a model that is used for code assistance. And then the bottom part, do you want to talk about that? So
a big concern is, let's say, for example, how many of us have graphics cards? And Okay. Oh, okay. Yeah. Hold on to them because I hear they're
Alex
in
doesn't.
short storage and not much availability. A lot of new models that are used for coding right now. So the one I like to give as an example is Qwen. So Qwen's, believe it's 3.6 that they just came out with.
Yeah.
Uses a special way of I guess inferencing the model so that you don't have all 35 billion parameters on your GPU at one time. So they kind of split it up into kind of 3 different portions so that you can essentially reduce that computational power at a huge amount, right? Because if this is released at its default precision, which is, sorry, I'm going into too much detail, but integer 16. So each billion parameter is going to take 2 bytes of storage. So you would need almost like 70 gigabytes of VRAM, and I don't think many of us have 70 gigabytes. So there's a lot of methods that they do, for example, quantization and this mixture of experts in order to reduce the amount of requirements that you need for your hardware to be able to run these models. And so I believe we'll be doing that in the demo today, is using one of these models that uses both quantization and mixture of experts so that you can run a really advanced frontier open source model on limited hardware. Yeah, so it's pretty cool tricks they do.
Right. So one thing that sometimes there's a little bit of a misconception, like, oh, I'm running this on my local machine, so I'm totally safe to use any model that's out there. That's not necessarily true, right? Because, well, first of all, the origin of where the model was trained, it could be somebody that actually trained it on some data that is, in the best case scenario, just not factual, or they leave out convenient facts. But it can go as far as if you give it access to tools. For example, I'm running my model locally to also just do stuff on my file system. If this is a model that somebody kind of trained for malicious kind of stuff, and you give it access to stuff on your local machine, on your, to your database or whatever more, it could potentially also take some actions that you did not want to do, right? So even with running models locally, you want to be a little bit careful of the origin of where the model came from and who trained it, because I think we're going to see that more and more, that there's going to be some funky stuff just because people are like that, unfortunately. Yeah. And then one more thing, because, okay, so we want to use a model on our local machine, but how do we know if it's actually going to be able to run on our local machine? So there's another cool little project that's called LLM Fit, and you can just install this CLI, and it's going to tell you which models are the best fit for your hardware. So that also can give you an interesting idea of, like, yeah, I want to use this really big model because it can do a lot of stuff and it's really accurate, but then when you actually run it on your laptop, it doesn't work because you don't have enough resources. So this kind of gives you an idea of, based on the use case, so you can see, you can tell it for general purposes, for code purposes, which model is the best for that, and then which one fits the best on my machine. So you got at least some idea of which model to choose. Now, how do we actually run these models on our local machine? Because one thing is getting a model. You showed a little bit of Ramalama, which is one of the projects that we're going to show. But maybe the most known is a different project. So how do we choose?
How do we pick? All right, who knows this game now? Yeah, my people. Smash. Every character has a different capability. The same goes for LLM tools. Because a lot of us probably familiar with this Olama logo. Anyone use Olama before? Awesome. Okay, what if I told you could make it go even faster? So there's other ways to run a model to make it go faster, to use more capable LLMs. One of these is running the default upstream project, Olama C++, that's based off of. One of them is running them with VLLM. There's a lot of cool hacks that these projects do to make these LLMs run really fast. We're also going to see LM Studio later on. Olama is great as a CLI or a tool that you can use. I think I have it running here. But the trick is, even though you can define a model file, you can do an Olama run, Olama serve, there's no real way to get to the next step. Like if you're going to production and you want to share this with your team, you're going to be severely limited, right? There's no clear path to production. And it also loads in all these accelerator files. So if you're running it in a container, it could be multiple gigabytes just for that infrastructure. So what are other types of tools? Well,
yeah, so one other tool that I use quite often because it has a nice UI and I can fiddle around with the parameters and the settings and the configurations pretty easily without having to like try to go through the help files and figure it out. So this tool is called LM Studio. I kind of hate to use it because it's not open source, and I really like to use open source stuff, but it works pretty well for kind of, especially when I'm using models to integrate with my AI applications, because I can change the configuration very easily. And it works pretty well on Macs, especially with Vulkan support, but yeah. And then the third tool, you already kind of saw it, is Ramalama. And it runs your models in a container, which has some really kind of interesting advantages.
Right, and so if I come into a new tab and I do a Podman list the running containers.
So everybody know Podman? It's basically like Docker.
Podman, yeah. Sweet. And you can see I have this Ramalama inference server, so I could run this my machine, your machine. It's going to have the same kind of underlying setup. And I could use multiple inference engines like Llama C++ or VLM. And so it's just a cool way to run it in a container and auto-detect the hardware, whether you're using AMD, Intel, CPU, whatever it might be.
Yeah,
so.
and you can actually have it create a Kubernetes YAML file to deploy to, production, or at least to a Kubernetes cluster.
To get you there.
Yeah, exactly. So, but at least it gives you something to hand over to your platform team if you want to take this further. Sweet. Yeah. So now we're able to find, hopefully, some models that we can use. We gave you a couple examples of running models on your local machine. There are other options too. You can actually use Docker as well, and as well as other tools. These are just the ones that we happen to use, and then also work on with Ramalama. But how do we actually use these for our local code? With our local code assistants, right? So we're going to take just a moment and we're going to switch laptops.
We're going to some magic. And while he's doing that, I'll explain real quickly some of the tools. So you've got open source tools like Continue or Roo that just exist in your IDE, so VS Code, IntelliJ. You've got stuff like OpenCode, which goes directly in your console, your terminal shell. And they just open source Claude code. So that was really nice, right? No, they didn't do that, but it is.
I know. I was like, really? Oh.
It is out there now.
Okay, so there again are many options. One is open code. That's one of the more popular ones, even though some people say that apparently PyDev is the latest and greatest. But anyway, so see, it keeps asking me to update now, and I say yes, and then it doesn't do it. So I'm gonna skip that part. Okay, so this is just part of your CLI, right? So you have open code, and then you can actually configure it to work with a local model. So in this case, you can see that I configured it to work with a local Qwen 359 billion. Via LM Studio. So you just basically tell it, switch models, and then you can decide which model to use. So you can say like use Olama, use LM Studio, or whatever. So the reason why I'm using this one is because I've already configured it. So if we go to LM Studio, which I have running right here, so if you go to just a basic interface, it just has a chat like you would expect from any kind of tool to work with LLMs, and then you can add your model. So it excuse me, also helps you find models pretty easily. You can search for models, and it also gives you some suggestions of what models you could use, which, if you're not really familiar and you didn't go through our whole explanation for choosing models, you can also just try to do it here. And then, so in this case, I've already selected a few models and downloaded them because on the conference Wi-Fi, we also have some issues, I think. So in this case, you can see that I have some models. So I have here a Qwen 35 billion, that's the one that we talked about earlier. I also have the 9 billion, so a smaller one, and then a Mistral and another Qwen, and then Gemma 4 and two Granite, so a Granite Tiny and a Granite Small. So I use them a little bit interchangeably. Well, not interchangeably. I use them for different use cases. But what's nice here is that you have this developer interface, and then you can also kind of make some changes to the configuration. So in this case, for example, if you want to use a model on your local machine for coding, the default kind of context of, I don't know what it is, it's very small, it's 4096. It's not enough, right? So you need to change the context length, then you probably want to configure the GPU offload, and then there's some more kind of configurations that you can make. I'm also not a super expert in this. I just play around with it when I need to and Google it a little bit. But yeah, so in terms of KV cache and stuff like that, to make sure that we have the optimal settings. And then you can load that model to use, for example, with your code assistant. So in this case, like I said, I was using open code here, and yeah, we also have our IBM Bob on the side, but for this use case, I'm just using open code. And again, there are different solutions here. So now I can ask it, what is this project about? Just something simple, hopefully. And the first thing that you'll notice is that it does take a little bit longer, right? So because this is all running on my local machine, it takes a little bit longer, especially if you start using bigger models, then it takes longer, but it also will be more accurate. So you kind of got to weigh between fast and more accurate, and find a balance between it. So you can see that it's thinking, and I need to understand what this project does by reading key files like the README and the pom.xml. So it's already figured out this is a Java project and needs to read the pom.xml, and it sees that, yeah, there's some cool stuff here. There's an MCP server with available MCP tools, and the app runs on this port and whatever more. Cool. And what about this MCP server Quarkus agent? So this is a separate little project that I just wanted to mention. So we on the Quarkus team, we're also working on, so you have developer experience, and then you have the AIX, the AI experience. So your code assistant actually needs some help too, right? So we're actually creating tools that you can plug into your code assistant that actually have knowledge about everything in your runtime and about the application. So for our Quarkus application, it has knowledge about all the extensions, the documentation to that. The extension can provide their own skills and everything kind of for your code assistant as well. So I just wanted to give a shout out for that. And that's what you see the description here. Like the Quarkus agent is a separate MCP server tool that helps code assistants interact with your blah, blah, blah. But anyway, so this is running on my local machine. The LLM was able to figure out what this is all about. Now, what if I want to use local LLMs for my actual code? And this is the wrong slide deck. That was the one from this morning. So let's see if we can find the one from today. And if not, oh yeah, now we need to go. Oh man, now I have to go all the way to where we left off. Sorry for this. You should play like some hold music. Like, yeah. Too bad we don't. Oh, I should have played the IBM Bob song that Alex created. Okay, so I showed you kind of how to use code assistant. So I use Open Code, which is a more CLI-based tool, but you can also use tools that integrate into your IDE as well. So there's like you mentioned, right? So there's Continue, RuCode, Klein, and those are projects that you can plug in. Mostly they support VS Code. There's also ways that they integrate with IntelliJ, but mostly they try to do VS Code and then create forks for that. So you can try those as well, and then also those you can configure to use a local model as well. And then some tips for local models.
Yeah. Oh gosh. So.
Oh gosh.
Okay, so since we're dealing with a model that's 9 to 30 billion parameters, that's kind of the sweet spot that you can run on your own machine. You're going to notice most of these are 27, 35 billion parameters. That's just because of how much VRAM or RAM they're going to use on your machine. But having additional kind of pointers to help this model out is super important. So this might be a agents or Claude markdown file, which essentially, because think about it, if the LM, every time you ask it something, is kind of like waking up from like a, waking up fresh, like from a coma or something like that, it's essentially has no knowledge of what happened. It's just fresh out of its training data and is looking at your project. It's a good reason to have like a markdown file that explains what's happening, the specific frameworks and libraries that you use, how you run the project, development mode, or do we want this, build config to be used. And so, do you have an agents file that we could see, or I think I saw one in your projects. But
let's see.
This is something like a Claude MD that you will just have in your repo. Oh yeah, one of those. Yeah, and so you'll generate this at the beginning or during the creation of your project. That kind of helps your model understand, hey, this is when we run the model in development mode. This is how we package it. All of these different configurations that you do, right, Kevin, that the model should also know about. This is going to save you so much headache, like so much time. And no matter if you're using Claude Code in a proprietary model or a local LLM, this is super helpful. This is the biggest tip for sure.
Yeah.
So that's pretty important.
Yeah.
Other tips, I would say, being very specific. So with Claude's Opus model, I can say, hey, I'm getting this output from a Kubernetes manifest that wouldn't deploy, fix it. And it would kind of call like 20 tools. It would use 100,000 tokens. And now I'm like $10 poorer, right? The way that we see local models being used for development is really specific. I'm having this specific bug. This is the context that I know about where the error happened. And here's probably some guide to get you started, right? Because, with OpenCode or any of these assistants, you can pull in from the terminal. You can pull in, stack trace stuff. You can, call an MCP server to your database. All of it is capable, but the context window is just smaller. So that's the biggest thing to know, right?
Yeah, exactly. So, and this is kind of maybe a not so fun part about this talk, but I actually do use local models together with frontier models. So basically, when I have a more complex task, I will use a more kind of mainstream code assistant. So, in my case, I'm using IBM Bob, but basically to give me a plan of what needs to happen, please break that down into smaller tasks, and then I throw the local models and the local agent at those smaller tasks, because they do struggle with the bigger context of like the big, especially when you have a bigger code base, and then it struggles. So you can also use the best of both worlds. So that, of course, that's using a little. It's a little bit of a cheat code, but it works pretty well.
I won't call you out on it.
Yeah. Okay, so let's create an application that runs locally with network optional. So if you're kind of like us, we do happen to travel quite a bit, and that means you're stuck on airplanes with very unreliable internet. So here, really, local models are a godsend, even for me when I'm creating local applications. And I am dependent on some AI development, because that's what we do these days in our team. And so, using local LLMs is quite convenient. So I'm going to close this agents file, and let's hide this terminal a little bit and show you an example of this application. So you already saw the description from the code assistant itself. I just want to point out a couple things here. So I have two different components to this application, and I like to call this local development because I have two projects. I call this the home bot, but it doesn't really do much. All it does is via MCP, it calls this NetAtmo MCP server. And basically, it goes to my weather station at home to get some information from my weather station, and then exposes that as an MCP server. So that's why I still call it local development, even though my home is not here, but it's still local. But I am using local models and everything, right? So you can see here that you can configure that pretty easily if you're using like Quarkus LangChain4j. You just say, I want to use the base URL of localhost 1234, which happens to be the LM Studio model. So if we go back to here, it is the model that's exposed here, or the model server. So here you can see that we have this LM Studio server running on port 1234. Sorry, it's a little bit grayed out. And then we have two models loaded. So the Qwen 359 billion and the IBM Granite 4H Tiny. So we also, of course, then need to specify which model we want to use. So in this case, I'm just going to use the Granite 4 Tiny. So it's a very small model. But in this use case, I just have a very kind of limited use case. I do have an MCP server, so it does need to be able to do tool calling, but that's it. And then I don't need to specify an API key because this is just local. And then just for completeness, I have the MCP backend running also on my local machine, or I will have it running on my local machine once I start it all. So I'm going to go ahead and hit exit here. We'll just close this. And then go to the backend, so cd netatmo, and then we're going to start up the MCP server. So this is this application right here. Oh yeah, definitely don't want that slash in there. And then, so just to kind of show you, if you've never created an MCP server, it's really simple. So you just add a dependency here somewhere. I'm just going to do find for MCP. Man, typing is hard these days, huh? So here you can see a dependency, Quarkiverse MCP, Quarkus MCP server, and in this case, we're using MCP server HTTP. And then based on that, I just have to annotate my services with the @tool annotation. And just by doing that, you're exposing this particular function as an MCP server in this application. And then you want to give it a good description so that the LLM knows what this MCP tool is for. And then I have a couple more. So basically, the first one just gets the current weather. Then there's get available devices at home. And then I can get the historical weather. So this is just a simple MCP server, just a few lines of code. And it is a REST client for basically a wrapper around an API service for my home weather station. So I have this running. And then on the other side, of course, I need to consume this MCP server. So I'm going to start that up, which is our home bot. And that's the actual Quarkus LangChain for J application. So in this case, you can see just in the dependencies, you just have the Quarkus LangChain for J. And then in the source, I have this chatbot, of course, because that's the easiest way to show this. And we have a weather endpoint for our chatbot service to call. So, and then we have here a really simple kind of system message that says you're a weather station bot, you have access to an MCP server that retrieves information, and then we annotate this with a MCP toolbox for the NetAtmo service that we have configured in our application properties, right? And so based on that, just a simple system message, then I can start chatting with my chatbot. So let's try that out with this really fancy UI. Yeah, I know. Hey, what is the temp in my backyard?
Private data here.
Yes, yeah, I know.
Blur it out.
Okay, the current temperature in your backyard is 16.7 degrees Celsius. So you saw it was actually coming back really quick, right? So this is an actual LLM running on my local machine, but it's a really small one. But for this kind of stuff, it's all I needed for just doing this kind of stuff. So as you saw before, when I was using the code assistant, I was using the Qwen 9 billion. Sometimes I use the 35 billion. So those are more capable for more advanced tasks like using a code assistant. But in this case, I just needed it for a simple MCP server with a really simple kind of chat interface. And it's pretty much quicker. Now, if I start asking some more complicated stuff like what was the lowest temperature last night, then it needs to actually do a little bit more work because it needs to gather the historical data. It needs to figure out what time frame to ask, and then basically combine all that information. But still, I'm happy that was actually faster than usual, so that's great. based on latest readings from your weather station, here's what we can share. The outdoor temperature was 17 Celsius, which seems like that's a little bit high since the daytime temperature was 16, and then the humidity was 85, whatever. Sorry? It's the wrong date. Okay, yeah, exactly. This was apparently in August. Yeah. What about May 6, 2026, though? So context matters, right? So of course you don't, it doesn't have, that's great, okay. I have until August, okay, this is starting to hallucinate a little bit, which is exactly what we would expect from a very small model. So this kind of proves my point, I guess, inadvertently, that based on the use case, you want to use different models. And in this case, it's very easy to get a quick result from the current temperature. But then once you start adding more complexity to it, it might start struggling a little bit, and you might want to use a more capable model. So maybe we have a couple more minutes. So I can also share a little bit more advanced use case where we start using a bigger model. And I'm going to stop my Quarkus local applications here. And I'm going to go, if you were in our session this morning, we showed you an agentic system that uses a lot of agents to do a lot of orchestration, and it's quite complex. So let's see if we can actually use a local model for that. Now, local in quotation marks, because I tried to use a local model for this last week, and even if it was the same model, the Qwen 3635 billion, it was struggling to the point where my laptop completely crashed. Now, local model can also be on your data center, right? It can be, maybe you have a really good machine at home that you can use for just serving models, or maybe you're lucky enough like us that we have available a model as a service, in this case from Red Hat, and there's the Qwen 3.6 that is hosted there. Now, wish me luck with this one because it doesn't always work so well. I'd need to unset the OpenAI API key because I wanted to pick up the one in my environment file, and then hopefully this will work. So as you can see, this morning we were using OpenAI, and we were using not the most advanced, so this is pretty cheap, the GPT-4o, but it is a remote model. In this case, well, it's local-ish, right? Okay, so let's try this out. Start up the application. And then you can see it starts up some test containers and stuff like that. And it should be using my remote model. Now let's see what happens here if I ask it. So this, as a reminder who wasn't in the session, this is kind of like a car rental agency, fictional. And the person that receives the car, they get the car back, and now they give it, you know, like, what's a funny thing? This morning I said the car was on the roof of the Wembley Stadium and crashed off, but it ran into the Tower Bridge.
No.
Car ran into Tower Bridge and it
caught fire.
Caught fire. Okay. So you can see it's processing, and so basically what's happening here is that this is a full-blown agentic system written in Java with Quarkus. So it has a whole bunch of agents that, based on the use case, are going to be called or not, and then it's going to try to determine the price of the car to make a determination if it should be disposed or not. So it needs to do a lot of stuff. Let's see if it's working. So based on the fact that it's quite slow, I'm going to think that it is definitely using not one of the frontier models. You can see it's processing.
It's got to figure out, is it a dent or?
Yeah. So, but you can see that it is eventually advancing. So it figured out that the previous condition was minor dent on passenger door, and we gave it the feedback, ran into tower, bridge, whatever. It caught fire. That's probably the best thing about LLMs, right? Even if you mistype it, they still understand you, which is really nice. So we're going to give it a little bit of time here. And then here, it actually advanced to the point where it hit the human in the loop tool. So now there should be a decision to be made. So basically the car analysis went through, it tried to figure out the value of the car. And then because it's an expensive car, a 2024 Mercedes-Benz, it doesn't just decide to dispose the car, it wants us to actually give our kind of a determination as a final human decision. But so this is what the LLM came back with. Although the C class has high estimated value and the exterior description notes only a minor dent, the reported collision with that tower bridge and subsequent fire indicate. So it was able to analyze our message and then make a decision. So we gave it, there's different agents that decide, should it be clean, should it be go sent to maintenance, or should it be disposed? And so in this case, it recommends that we scrap the car, but we can override it still. We can say like, well, actually, I want to keep this car still because it has a lot of value, and then override it. So let's try that.
Facebook Marketplace.
Yes, exactly. Facebook Marketplace.
slightly used.
Yeah. And then after a while, it will eventually get to the final result of, in this case, we'll send it to maintenance. But this is a very kind of complicated application for a local LLM to handle. So in this case, it was kind of a local-ish, right? So it is a Qwen 3.6 that I do use on my local machine. But for this use case, like I said, I could have tried to do it on my local machine, but I didn't want to risk my laptop completely crashing. So I cheated a little bit, but it is in our data center. So you can imagine, you can play around with this, maybe have a more powerful laptop, and you can try it. I could have used maybe a slightly smaller model, but then the accuracy goes down. So it is kind of that balancing of everything. So wrapping it up, I guess.
Yeah. Well, first off, thank you guys for being here. Remember to pick the right model for the right use case, whether it's for coding or whether it's just for pulling from an MCP server. Very important, make sure it comes from a reputable source. We recommend Hugging Face. If you look up Red Hat on Hugging Face, we publish most of the models and compress them for you. There's tons of options out there, from Olama to LM Studio, and they work, but have those realistic expectations that it's not a frontier model, and there are some use cases for frontier models, like designing a spec, or some use cases for local models. You might have to ask for a hardware upgrade, right? Like one of these bad boys. You can definitely develop these agentic apps even with local models, and check out Quarkus, right?
Yeah. There's really cool stuff in Quarkus. I just scratched the surface of what you can do with it in terms of AI development. So if you haven't, definitely take a look at that. And then I think that's it. So we shared the slides, I think, somewhere at the very start. Is there? No, but maybe we hit it or something. Let's see.
Yeah, there we go.
There it is.
And here's the slides. Thank you guys so much. Enjoy the rest of the conference. See you tonight.
Yeah, thank you.